Hi, I'm Mini, Assistant Professor in EC Department from Emmanuel Arasar JJ College of Engineering. Today, I'm going to explain the topic Voltage Series Amplifier. Voltage Series Amplifier. This is the topic taken from feedback amplifiers. Okay. So we should know what is meant by amplifier, right? What is meant by amplifier? Amplifier amplifies the signal to stronger. Okay, if the signal is weak or if the input is weak, okay, it will make to stronger. That is the purpose of amplifier. Okay, then real life also we are used to this amplifiers. Okay, then do you know some of the real-time applications or amplifiers? Okay, we know an amplifier takes the weak signal, right, and make it stronger while keeping the information in the signal. Then real-time example we can say mobile phones, right? The microphone produces very small electrical signal from your voice, and the amplifier increases the signal so it can be processed and transmitted, right? If you take the audio speaker, here the phone or microphone produces a weak audio signal. The audio amplifier increases its power and sends it to the speaker, producing louder sound, right? So microphone to amplifier, amplifier to speaker. Okay. Then any other example? Real time example, can you remember? Okay, radio, right? Radio. The received radio signal is very weak. Okay. So if we used the amplifier, it increases its strength so that the audio can be heard clearly. Okay. Any other real time example? Okay. So every day we are used on electronic item. What is that? Television, right? In television, amplifiers strengthen the weak signals received by the TV so that the picture and the sound can be properly processed. Okay, so simply the amplifier does not create any new information, but it increases the strength of the existing signal, right? Are you clear? So amplifier, it does not produce any new information. Okay, so if another one important thing, this if you used amplifier, the input is very important. If you are not give any input, it will not produce the output. Okay, so but when comparing with the oscillators, okay, if you are not give any input, it produce the output. But this amplifiers, it doesn't take that process. Okay, if you give the input, it will produce the output very clearly and strengthen, right? Okay, now I think you all clear about that amplifiers, right? Now we will see about that feedback amplifiers. Okay, so this feedback amplifier, it's an amplifier in which a small portion of the output signal is returned to the input, or we can say fed back to the input. This is what feedback amplifiers. Okay, so actually what is the basic block represents? We are giving the input to the amplifier. From amplifier we take the output. Again from this output some samples are, because we are unable to receive that desired signal. Okay, that's why we again and again, in order to receive the original or desired signal, we take some samples, okay, to the input. Again and again it will process, we get the better output. Okay, that is, the output is checked and small part of it sent back to the input. Okay, so if you imagine a microphone, it consists of amplifier and speaker. Okay, if you speak into the microphone produces the weak electrical signal. Okay, but this amplifier produces a weak signal into a stronger. Okay, the speaker produces this sound. Again, a small part of the output can be fed back to the amplifier. This feedback can be used to control and stabilize the amplifier's performance, right? Then why this feedback is used? Actually, why this feedback is used? Improve stability, reduce distortion, and the gain also controlled. Okay, but the bandwidth is increased, then reduce the effect of component variation. Okay, then this feedback, actually this feedback is two types of feedbacks are there. Okay, positive feedback and negative feedback. In negative feedback, so in amplifiers we are used negative feedback, but positive feedback is used as an oscillator. Okay, so in negative feedback, what is mean by negative feedback? A portion of output is fed back in opposition to the input, or we can say both are out of phase. Okay, generally reduces the gain, but it improves the stability and reduces the distortion. Okay, positive feedback is what? The feedback supports the input, it increases the gain. Commonly we can use this as oscillators. Okay, if you consider the thermostat, okay, think about the thermostat. We can set the temperature. Okay, the sensor checks the output. We can say that it sets the room temperature. Okay, and sends the information back to control the heating system. Okay, so we will set the temperature which is given to the heating system. It will check the room temperature, and the temperature sensor give the feedback to the uh, again give the feedback to the input to set the temperature like this. Okay, so somewhat the temperature will be arranged. Okay, similarly in feedback amplifier, the output is monitored and the portion is returned to the input to control the amplifier's performance, right? So first we studied what is amplifier and what is mean by feedback amplifier. Now we come under the topic. Okay, these are the introduction about the feedback amplifiers, because this topic is taken from feedback amplifiers. No, okay, in feedback amplifiers, some of the types of feedback amplifiers are there, right? So what are the types? Voltage series feedback amplifier, voltage shunt feedback amplifier, then some other, can you remember? Current series, because we already discussed in feedback topology. Okay, so four types of feedback topology we already discussed, right? So the third one is current series feedback, and the last one is current shunt feedback, right? Now voltage series amplifier. Okay, so what is voltage series amplifier? So in feedback amplifier, three blocks are there. Okay, input, amplifier, output. Okay, we are taken the small part of output to the input. No, okay, so we consider that as a sampled network. Okay, so using the sampled network, we are connecting the feedback amplifiers, and again it will mix with mixing network. Okay, so in that mixing network, the source as well as the feedback will be mixed, which is given to the input of the amplifier again and again. Okay, so see the diagram of pictorial representation of voltage series amplifier. Okay, so here the sampling, the feedback network connects in parallel, right, across the output to pick off a fraction of output voltage and send it back to the input, right? So here what is sampling in this circuit? Okay, the feedback circuit taps the output voltage. It treats the output as a voltage source. Okay, this parallel connection helps lower the output resistance of the amplifier. Okay, see the input side, it's the series mixing, right? Input connection. The part, because in actual block diagram, the series network the mixing network consists of series mixing and shunt mixing. Okay, So here the part of the voltage taken from the output is put in series with the input signal source. This series connection raises the input resistance of the amplifier. Okay, so in this, what is the effects of voltage sampling? Lower output resistance, because the parallel output connection divides the output resistance by 1 plus a beta, right? It stabilizes the output voltage, keeps the output steady even if the load changes. Okay, then see this diagram. So what do you understand from this diagram? This is the basic amplifier. Its gain is A. Okay. So before that, it's the input. Okay. Here in that input side, the mixing network is there. We are connecting the feedback by series mixing, right? So series mixing means, what is the source used in the input side? As we know already, the current in parallel, because you studied Norton's theorem and Thevenin's theorem, right, for circuit analysis subject. For Norton's theorem, using current source parallel with resistor, right? Similarly, for Thevenin's theorem, we used voltage source series with resistor, right? Same here also, use the same concept at the input side, but in output side we will reverse the process, right? For input side, if you used current source, we parallel with the resistor. If you used current source as in the output, it will reverse. We are not used the resistor as parallel, but instead of that we used that resistor as series. Understood? If the voltage source is series with the resistor, this process, this pattern we take in the input side, but in output side it will be reversed. If we used the voltage source in the output side, we connect the resistor with parallel. Understood? Okay. So from this we clearly understand, here the source is the voltage source and the output is the voltage. Okay. So now what is the gain of the amplifier? What is the gain of the amplifier? The gain of the amplifier is, it's the ratio of output voltage to input voltage, right? So both will be a voltage term. So we can say this as a voltage amplifier. Clear? Okay. So what is that block present below the basic amplifier with the gain? That is feedback network or feedback factor. What is the representation of feedback factor? Beta, right? So what is the other name of voltage series amplifier? Series shunt feedback amplifier. So see this slide. It is also called as series shunt amplifier. Here the sampling parameter is voltage and the mixing fashion is series. What is the general gain? Output voltage by input voltage. So simply we can say this as a voltage amplifier. Okay. So what is the output voltage now? Which is equal to gain into input voltage. So we understand the output is directly proportional to input voltage. Okay. So we can simply say this amplifier as a voltage amplifier. Okay. See the diagram. This is the equivalent circuit for analyzing the voltage series amplifier. Okay, what do you understand from this diagram? This is the source resistor, right? So because we know that the input is a source, that's why we connect the source resistor here. Okay, so we can add the resistor series with the source resistor. Okay, if you need, we can add this. Okay, then this is the symbol of transistor. Okay, so as we studied already, for H parameter model, what is the input of the transistor? HIE, right? Instead of HIE, here we just represent the HIE as RI. Okay, what about the output? The output parameter must be source, right? Source with resistor. Okay, here voltage series amplifier, we understand the source is voltage source. Okay, so AV into VA, how this value comes, so that will see in the next step. Okay, if you find the transfer gain or transfer ratio, we will find the value V0. Okay, then we are connecting the voltage source, that's why the resistor will be connected in series. Okay, then finally the load resistor, we can observe this is the output voltage. Okay, see the circuit diagram clearly. Okay, first we find the transfer ratio. How will you find the transfer ratio? It's the ratio between output voltage to input voltage, right? This is the basic definition. Okay, we can represent this as a voltage amplifier because the input, the output, both will be the voltage. Okay, that's why we can say that as a voltage amplifier. Okay, so first we understand the voltage gain without feedback. So AV voltage gain is equal to output voltage by input voltage. Okay, if you are not used to feedback, the source will be equal to input voltage. That's why V0 by Vs, which is equal to V0 by Vi, because the source and the input both will be the same one if we not used feedback. Okay, if we used feedback, what happened? The term AV becomes AVF. Okay, AVF is equal to V0 divided by, now what is the input? The input consists of input as well as feedback, right? That's why, so we can add this term Vi plus Vf. Okay, then the feedback factor, so we represent the feedback factor as beta. Okay, what is the output of here? This is also ratio, output by input. See the diagram, this is the diagram, right? What is the output here? See the feedback factor. Okay, what is the output? Vf. What is the input? V0, which is taken from output. Okay, that is the input of feedback. That's why beta is equal to Vf by V0. Okay, so from this equation we will find that Vf value, Vf is equal to beta into V0. Okay, so as we understood from equation 1, okay, what is V0? V0 is equal to AV into Vi. That source is represented here. The voltage source is AV into Vi. Okay, now we substitute the Vf as beta into V0. The V0 is AV into Vi. Understood? So this is about transfer ratio. So in transfer ratio, first write the definition, then how to represent the amplifier using that ratio, then gain without feedback, then gain with the feedback, then feedback ratio. If we substitute all the parameters inside that, we will find the AVF. You already know, if we used feedback amplifiers, the gain will be reduced. Okay, but the bandwidth increased, distortion reduced. Okay, so many advantages are there, but the gain should be reduced. Okay, by the factor 1 plus A beta. See here, now we substitute the voltage gain with the feedback. So V0 divided by Vi plus, instead of Vf, we substitute beta into AV into Vi, because the Vf value is equal to beta into V0. Okay, then V0 value also AV into VA, already you studied. If you substitute all the values in AVF, okay, see the denominator term, the VA is common, isn't it? Take this VAS commonly outside. Okay, now numerator having VA as well as denominator is also have VA. We cancel both terms. The remaining term is AV divided by 1 plus beta AV. Initially we explained that, isn't it? What is that? The gain should be reduced. How it will be reduced? By using the factor 1 plus A beta. The answer will be get, right? AV is equal to AVF is equal to AV divided by 1 plus A beta. Okay, next we will find the input resistance. How will you represent the input resistance? Ri. Okay, then what is the general formula for resistance? R equal to V by I. Same formula we implement here also. First we should find that input resistance without feedback. That is what? Ri, okay, equal to the general formula R equal to V by I, no? Instead of V here we are used that the source is voltage, right? So Vs divided by, then the current will be II. Okay, both will be the input only. Now, which is equal to Vi divided by Ia, because I already told that if you not used feedback, the source will be equal to input, right? Next, the input resistance with feedback. How will you find that? We will represent that input resistance with feedback as RIF. Okay, RIF is equal to, what is Vs now? The Vs becomes, it consists of input as well as feedback, no? So Vi plus Vf divided by Ii. So beta equal to Vf divided by V naught. Okay, so we already derived that the Vf is equal to beta into V naught, and beta becomes AV into Vi, right? Now we substitute all the parameters in RIF. RIF is equal to, see, RIF is equal to Vi plus the Vf is already we find beta into AV into Vi divided by Ii. Okay, so from this equation take this numerator term, Vi is common, take this Vi commonly outside, so remaining that term is 1 plus beta into AV. Okay, so we will reduce the term as from numerator Vi in denominator Ii. What is Vi by Ii? Ri. Okay, so this is the expression to find the input resistance. Okay, so do you understand? For finding the input resistance, first write the basic definition or basic formula used. Okay, so initially we are not used any feedback. What about your input resistance? And finally we are included the feedback amplifiers. Now what about the input resistance RIF? Okay, so if you used that feedback factor, substitute all the things, we get the answer. I think you all understand. See? Next one, output resistance. So initially I show the image. This is the input resistance. To find, in order to analyze the amplifier, we are using the equivalent circuit. Okay, see the equivalent circuit. We are now completed the input resistance with the feedback RIF. Now we come under the output resistance. You consider the output side, but we follow three conditions. Okay, the condition is the input, you should make the input as 0. How to make the input as 0? Here we are used voltage source, right? So how this voltage source to become an 0? The voltage source is short circuited, it makes it a 0. If it is current source, what should you do? It will be open circuited, then we will make this as 0, right? So same procedure here also, we must follow three rules while applying or while finding the output resistance. The first rule is what? We should make the input as 0. What is the second case?